Hi, this is a short lesson on ordinary differential equation, in particular first order linear differential equation. So an equation of the form dy by dx plus p of x times y equal to q of x. Let's call that equation 1. This is really the standard form of linear first order differential equation. In order to solve a first order differential equation, we will be looking at what we call an integrating factor. And the integrating factor is identified by, so let's just write the integrating factor, and let's denote that by mu of x. It's identified by e to the integral of p of x dx. We then multiply both sides of equation 1 by the integrating factor, and that will result on the left hand side being an exact differential, and all we have to do then or worry about is to integrate mu of x times q of x. Now let's illustrate this fact by an example. So an example here. So let's consider the differential equation dy by dx minus 4 over x times y equal to x to the power 4 e to the x. Let's call that equation 2. Now if you look at equation 2, you can immediately identify p of x, which is minus 4 over x. So this means our integrating factor mu of x is equal to e to the integral of minus 4 over x dx. And I'm sure that most of you or all of you would be able to integrate that. So you will have e to the minus 4 ln x, which can be written as e to the ln x to the power minus 4, and this is simply equal to x to the power minus 4. So that's our integrating factor. So we're now going to multiply x to the power minus 4 by equation 2. So let's do that. X to the minus 4 times dy by dx minus 4 over x to the power 5, multiplying by x to the minus 4 here, times y equal to simply e to the x, because x to the minus 4 cancels out the x to the 4. Now if you look at the left hand side, is an exact differential. And what I mean by that, if you differentiate, this can be written, in the way d by dx of y times x to the power minus 4. And if you differentiate that using the product rule, you will get back to the left hand side here. And now we have the right hand side is equal to e to the x. We haven't changed anything here. We now separate the variables, so I will have the integral of 1 d y x to the power minus 4 equal to the integral of e to the x dx. Now note here I say the integral of 1 d what's inside the bracket. So I'm basically now integrating 1 with respect to this what's inside the bracket, which is y x to the minus 4. You could, for convenience, call this capital X if you like, and you integrate 1 with respect to capital X, you will just get capital X. So this means that the left hand side will be just y equal x to the minus, y times x to the minus 4 equal to the integral of e to the x dx, which we can identify as e to the x plus a constant. Now, you could simplify, let's call this equation 3. Equation 3 is really a general solution to this, to the differential equation, which is equation 2. We can simplify it by multiplying equation 3 by x to the power 4. So then I will have y equal to x to the 4 e to the x plus c x to the 4. And that is the general solution. Thank you.